All right, we're back. Part 2. It's time for what you guys have all been waiting for. We're going to start cracking some stuff open. As you saw in the previous video, I showed you my thoughts on these. Really intrigued to see what's inside one of these. Choice here, so go ahead and plug your ears. And we'll probably fast forward through this just so you don't have to bear with all this time. Look, it's beach sand. All right, so there you go. This is why I say this is snake oil. To call this a surge arrestor, in my opinion, is actually a little criminal. Those metal rings right there, one is attached to each wire. You can actually see the copper wire in the middle of it where they crimp it on, stick it up to the ceramic. So the issue here is that spacing, and this is math, you can look it up, you can measure this yourself. We can measure this with some calipers and get you the number if you want to verify it yourself. But this spacing right here at, whatever voltage, you can calculate how much voltage it takes to jump that gap. And math says it's about 8,000 volts if my memory serves. And as you saw on the fencer, every now and then, it doesn't actually conduct at 10,000 volts and it lets 10,000 volts through. The silicone is there, the silica sand is there. The theory here is that if there's a lightning strike and lightning bounces across those two gaps, that sand is supposed to turn to glass and basically seal this thing up so that this plastic doesn't catch on fire. But you probably can find videos on YouTube, this end melted off and this on fire and dripping burning plastic from a surge, from a lightning surge. So that's my real beef with that one. That's, full on, end of discussion. That's my beef with that one, is it is just a spark gap. It has, you literally could do the same thing by taking a piece of wood and putting the wires like that up through the piece of wood and leaving it sticking up like that somewhere where nobody could touch it. It's going to jump the gap just the same as it is in there. So, useless in my opinion. All right. I think we determined we may or may not need to crack open a midnight. Might as well. All right, go ahead and plug your ears again. We'll be right back. Probably one of the most important things I failed to mention so far is that plastic melts back together. That wasn't it. There is a UL standard for surge arrestors. 1443, I believe it is. 1449, UL 1449. So midnight is listed to that. The EMP shield, I believe, is also listed to that. Yeah, 1449. The Delta, on the other hand, is not, as you can imagine, because it's not a surge arrestor. They did get a UL listing on some models, but if you look the listing up, I forget the number now, but if you look it up, it's listed as a filter. I guess it's filtering sand. I don't know. Freaking mess. So inside the midnight, as I said, it's going to be quite similar to any other MOV-based arrestor. Of course, obviously, in the big things in the room are your two MOVs, one per channel. The rest of the circuitry on here is really just to light the LEDs, which I got into with the vibratory tool. Sorry about that. They basically measure voltage or look for voltage between a couple wires to turn the LED on to make sure that, if that LED goes out, that means this is bad. These fuses here, what happens is when these finally give up the ghost and they've done all they can do over a period of time, they short completely and hold it down. These fuses will either blow the breaker or open so that there's no fire danger. And all of these have something like this in there. So that's really all there is. You two MOVs, some circuitry, and the fuses to open if there's a complete short before it melts anything down. So we're going to crack this one open. This one is a little bit of a horse of a different color because they have done something interesting, which I'll show you in a minute. But they use basically a Carlin PVC box and a weatherproof cover, blank cover. So I'm going to bet a nickel there's a Phillips screw somewhere right in this ballpark. Maybe it's a regular screw. There's something under there. I can see it. All right, so after investigation, it's actually a rivet. They've riveted the cover on. Yep. So see, any of you guys that have ever done, basic electrical work, here's the, I don't know, the foam gasket that comes with the actual outdoor receptacles and stuff like that. So here's where I say they're a little, I don't want to say sneaky, because I guess maybe they have a reason, but potting is expensive, and they have potted this whole thing. Rather than boring you guys for a whole bunch of time, I'm going to start hacking at this thing, and we'll leave the camera on. If we come across anything interesting, I will explain that as we go. I'm going to go ahead and get my wires out of my way. And I think I'm just going to start cutting on the case. All right, so we're deeper in here, and you'll see I'm finding exactly what I thought I'd find. Very tiny metal oxide varistors. I don't know if you guys can see that. I'm going to keep digging, but I just wanted to kind of point it out. You can see the circle, and it's about just under an inch. So I think this is what they call a 25 millimeter MOV. And you can see here, if I stick my knife in here, right about here is the thickness of the MOV. So it's 25 millimeters by, roughly probably an 1/8 of an inch thick. So about an inch by an 1/8 of an inch. And in comparison, I mean, these are square, so it's not quite the same, but these are 1.5 inches, and let me see if I can get someplace where there's no fuse. And they're about 3/8 of an inch thick. Because I have a hard time believing 3 MOVs per channel is 20% stronger than that big one. Again, I don't know if you guys can pick this up on camera. Yeah, camper. Yeah. Like in here, you can kind of see like the strands of the pin or the wire. See how there's something poking through? And you can see on these how they're just a nice smooth dome. So what would have happened here is these parts would all been put on this board like this. And this would have run through what they call a wave solder machine. They would have splashed hot solder up on the bottom of the board, and it would stick to everything. So the holes that don't have anything through them would still plug if they didn't have solder mask on them, but they wouldn't have any wires through it. That's how I know there's nothing on the board. But anyway, we're going to keep going. We'll be back. All right, so after about an hour, I've got this, and I look like this. So I've exposed everything on the board with the exception of breaking one little part. So this board here was up in the top of the box, and it has the LEDs in it. You can see how that one has 2. This one had 1. The wire comes down to this board right here. And along this back edge, there's a series of resistors they put on there to drive the LED from the channel. And I did knock that one resistor off. So what we did find for sure is 6 MOVs, about 24-ish, 25 millimeter, real thin ones. 3 per channel, so 3 from black to ground and 3 from red to ground, and you can see the layout of the circuit board there. The other thing we found is 20 amp fuses. So like the Midnight SPD has these thermal fuses here that heat up and desolder themselves. These have fuses internally that will blow if there's a short in this that loads the circuit before something catches on fire to blow the fuse, is what that's there for. And then we found 2 more interesting things. Where's my pointer tool? So right down here, these 2 things here, I believe are gas tube discharge or gas discharge tubes or whatever they call them. And you can see there's a spot up here for 2 more. If you was like on this one, there's probably 4 of them in there. You see there's a whole nother side to this board that's not being used. 2 more fuses, more MOVs, and more of these things, which I think from quick research, transorbers or absorbers, what did they call them, Sue?
Transorbs?
Transorbs, yes, that's right. Yep, transorbs. I really don't know what the purpose of these are, and they're only one, they're all in parallel. So I don't know if they're like between the red and the black, or what they do. But these here, for me, are the key. So the gas discharge tubes, from my understanding, are like super fast. These are what's supposed to grab it in that nanosecond or microsecond, whatever it said it was supposed to grab it in. These are supposed to conduct quick enough to catch an EMP in theory and give these time to kick in. So think of it as like just a little bit of a boost until everything else is in place. So that actually may mean these have some EMP stopping ability. What do those two little discharge tubes make it worth an extra, 200 and something bucks versus something like that? Only you can decide that. They look awful small to me to think that that's going to stop an EMP. This whole thing looks small. Those MOVs look small. I mean, I guess there is 3 of them compared to the 1 per channel. But that seems like it seems like not a lot of stuff for 300, and I think it was 350 bucks we paid for this thing. Yeah, we did buy these, by the way. We didn't. We did pay for these so we could tear them apart. That said, I mean, the quality seems nice. It's simple. There's not a lot of parts on it. The potting compound is super. It's not super hard. It's dense and sticky. Like, not sticky as in it's sticking to me now, but it's stuck to everything. And it does appear that they glued their MOVs together. You can see I tried to separate MOV 1 and 2, and I broke it in half. So if anybody wonders what's inside an MOV, it's just a little, almost looks like rock. I don't know what it is. Metal oxide, I guess. Well, probably. I don't know. I'm not an engineer. I just tear stuff apart. So, yeah, that's what's inside this box. Well, this box probably has another set of MOVs and, all the stuff over here, which is rather interesting because that means this box has twice as much stuff in it and costs the same amount of money. So, go figure. I mean, I'm sure they're charging a lot for all their promotion, all their advertising. The cost is not this. The cost is everything. As anybody knows, when you manufacture something, whether it's a camera you guys are being recorded on or no, I'm being recorded on, you guys are watching this, whatever it is. So the cost is not in the actual pieces itself. So, yeah, I don't know. Hopefully that was helpful. I don't know much about gas discharge tubes, but I'm going to keep this. I'm going to try to clean it up. I'm going to try to do some research. And if I find out any more about it or anything more interesting, I'll do a follow-up video. But it is definitely got more parts in it. They are doing something more to react quicker. So to summarize, at the end of the day, super fast, may help you with an EMP. Who knows? They claim it will. I think with an EMP, it's sort of a loaded question. Well, lightning strike's a loaded question too, but definitely one of the fastest ones I've tore apart. Pretty standard issue, like any other surge arrestor that uses MOVs. Quality, decent, works very well, affordable. So if you need a bunch of them, snake oil, don't waste your money. So hopefully you guys find that helpful. Thanks for watching.